Alright, we're working the second problem here. We're working a pitcher of lemonade. The concentration units are there. Before we get to that, I'm going to do the work on a separate sheet of paper so that it's easier for you to read. Now, the problem is given, the concentrations of the species listed. Here, molecular weights are given, so we're going to work the problem starting with the solution. Now, we are going to work with a single serving, which means that we're going to use 236.6 milliliters of lemonade. Now, given the density, we can convert this to grams. So there's 1.16 grams in 1 milliliter, because a cubic centimeter is the same. So the total solution is 274.456 grams. So we've got our volume of solution and we've got our mass of solution. Now, later we'll go on and find our mass of water. But our next step is the limonene, okay, which we know is 0.09%. Weight, that means it's X grams over 274.456 grams, which is a total mass times 100. So we end up with 0.2470104 grams of limonene. Now, we're going to need moles. As long as it's a solid, we just need grams and moles. If it's a liquid, we'll need milliliters. 136.2364 grams per 1 mole. So we have 0.0018131,01344 moles of limonene. So we're done with our limonene. Okay, our next one, we have limonene, we have sugar. Let's add some sugar, which is also known as sucrose, so I'm going to write it in there. Alright, by definition, we're told that in a single serving, we're going to have 24 grams. So we have 24 grams of sugar. Well, we're given the molecular weight of sugar, which is 180.1572 grams per 1 mole. So we know we end up with 0.133217 moles of sugar. Okay, that one was easy. Then the next one is the food dye. It's the yellow food dye, and so oops, I'm going to go ahead and do the vitamin C, which is also known as ascorbic acid, so I'm going to call it AA. And again, we're told that it's 425 milligrams, so it's 0.425 grams. Okay, and again, we need our molecular weight, which is 176.1256 grams per 1 mole. So we end up with 0.0024130507 moles. Now, if you want to write this in scientific notation, call it 2.413 times 10 to the minus 3. That is perfectly fine and acceptable. Okay? So now, let's do my food dye. I like to keep things kind of in order. So our food dye, we're told, is 694 ppms, which means that's X grams over the total mass, which is 274.456 grams, times ppms is 10 to the 6th. Okay, we solve for X. We find out that it's a whopping 0.190472464 grams, using the molecular weight, which is 534.36 grams per 1 mole. Alright, so That gives us 3.56449 times 10 to the minus 4 moles. Okay, this has been fun so far. So we've got our solution mass and volume. We've got our grams and moles of limonene, sugar, vitamin C, and food dye. Now the only thing we're missing is the water. Well, if we look at it, I'm going to come back up here. The water plus all the ingredients is equal to the total solution. So if we have the water plus 0.2470104 grams of limonene plus 24 grams of sucrose plus 0.425 grams of ascorbic acid or vitamin C plus 0.190472464 grams of food dye. This is going to equal the total mass, which is 274.456 grams. Okay, so we're going to simply subtract all and find out that the water mass is equal to 249.593517 grams of water. Well, again, we're going to need the molecular weight, which is 18.0152 grams per 1 mole. So we have a whopping 13.854 60706 moles. So we've got now our mass of water. Now remember, the density of water is 1 gram per milliliter density. So that grams, if we were to need it, is 249.593517 milliliters of water. Okay, I don't think we're going to need that. And then again, the total moles of everything is all the moles combined. So if we start back up here, we have 0.0018131011344 moles of limonene. We have 0.133217 moles of sucrose, sugar. We have 0.0024130507, which is our ascorbic acid or vitamin C. And we have 3.56449 times 10 to the minus 4th moles of the dye. And our lovely water, which is 13.854600706 moles of water. So when we combine all of that, we get a whopping 13.9924 moles. Okay, so I think we have everything now to work the problem, so I'm going to move this page to the side and we're going to fill in what we have, again using the values. So this is the molarity of sucrose, which we have 0.133217 moles per. Here we need kilograms of water. We have 249.5 grams, which means we have 0.2493517 kilograms of water. When we do the math, that comes out to be 0.5333735. We're going 4 places after the decimal, so our answer comes out to be 0.5337. Okay, our molarity here is 0.133217 moles over our volume, which we know is 0.2366 liters, which comes out to be equal to 0.56304773. So the molarity is 0.5630. Okay, so now we're at the molarity of ascorbic acid, and that is 0.00241305 moles over our 0.2366 liters, which gives us 0.01020, because our actual answer comes out to be 0.010199. So if we're doing 4 digits, non-zero digits, 1, 2, 3, 4, so that has to roll over to a 2. Now, this one has to do with the equivalence. Well, if we look at it, how many hydrogens are sitting out front because it's an acid? So remember, it's the number of equivalents times the molarity. So we've given the molarity that we have 1 equivalent. So 1 times that will give us that answer. So here, normality and molarity are actually the same value. That is not always true, and it's usually most likely not true. This is the mole fraction of limonene, which means that we need excuse me, the moles of limonene, which is 0.001813101 moles, over the total moles, which we found to be 13.9924 moles. Multiply that out and we get our mole fraction equivalent to I've got an answer and it's totally wrong, so let's real quick, we'll do it. 0.001813101 divided by 13.9924. So it comes out to be 1.296 times 10 to the minus 4, because the actual value is 1.295775556 times 10 to the minus 4. And if we're keeping 4 digits, we're done. So here is the molarity, which again is the moles, 0.001813101 moles divided by the kilograms of water, which we know that the kilograms are 0.249593517 kilograms. Okay, and that comes out to be 0.007264. There's a 217 after that, but we don't need it. Now the mass in milligrams of the food dye, and that is per serving. So wait, we already did that one. So the food dye we know is that many grams, which makes it, we just move it, so it's 190.0472 milligrams. And then the last one is our mole fraction of water, which that's most, so that's 13.85460706 moles divided by the total moles, which is 13.9924 moles. So this comes out to be 0.9901523. 4 digits is 0.9902. So at this point in time, we've worked the problem. Remember, we're looking for grams and moles of each species. This is solid. And volume if it's a liquid. But it's the same stuff over and over. So I'm going to stop this now and post it, and we'll be good to go.